Hey everyone, we'll get started here shortly. So I'm just getting a video ready here.
With Nagaro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
All right, great. So today we have a speaker that's part of the Litmus community. Jintao is a technical expert, and he's been working with Ingress controllers and very active in the open source projects. So today what we're going to learn is actually just how he's worked with that to have some good use cases, find some bugs. And what we have is a video that we'll play, but he's available to answer questions throughout and the Q&A. If you want to say hello, you can, Jintao.
Yeah, hello.
Yep. Hey, see you. So I'm going to click on your video here. There we go. It's just loading. All right.
I'm Jintao, an Apache APISX PMC member, maintainer
If
of
you turn
the
up your
Kubernetes Ingress
volume,
Nginx
you'll be able to
project
hear.
and Microsoft MVP. If you would like to get in touch with me, you can find my GitHub profile and email address on the slide. In this talk, the agenda is to discuss why we need chaos engineering, how to design chaos experiments for an ingress controller, how to practice it, the benefits and the future of the field. First, why we need chaos engineering? Let's review the definition of chaos engineering. Chaos engineering is the discipline of the experimenting on a software system in production to build confidence in the system capability to withstand troubles and unexpected conditions. Chaos engineering is the process of evaluating software system by simulating destructive events such as server network outage or API throttling. In this process, we test the system's resilience and reliability in unstable and unexpected conditions by introducing the chaos, for example, faults with the system. Chaos engineering can also help teams simulate real-world scenarios in a secure control environment to uncover hidden risks, monitor bugs, risks, and identify performance bottlenecks to in distributed system. This approach is an effective way to prevent system downtime or production interruptions. Netflix approach the approach to handling system inspired us to take a more scientific approach, thus driving the both and development of chaos engineering. Okay, let's introduce the introduction of disruptive events. Chaos engineering involves introducing disruptive events such as network partitions, service degradation, and resource constraints, or to simulate real-world scenarios and test the system's ability to handle unexpected conditions. The purpose of this is to identify an risk and use the information to improve the system's design and architecture, making it more robust and resilient. Next one is testing system resilience. Today's technology landscape is constantly evolving and fast-paced. To ensure that systems are robust, scalable, and able to handle unexpected challenges and conditions, it is essential to test the system resilience in real-world scenarios. Chaos engineering is an effective way to do this. It involves introducing distributive events to observe the system's response and measure ability to handle unexpected conditions. To measure the impact of disruptive events on system resilience, organizations can monitor system logs, performance metrics, and user experience. By tracking these metrics, organizations can gain a better understanding of the system's behavior and identify area of improvement. Next one is discovering hidden problems. Distributed system can be prone to handle issues such as data loss, performance bottlenecks, and communication errors. This problem can be hard to detect as they often only become visible when the system is under pressure. Chaos engineering can help uncover this hidden issue by introducing disruptive events. This information can then be used to improve the system's design and architecture, making it more resilient and reliable. By proactive identify and resolve these problems, organizations can enhance the reliability and performance of their system. This can help prevent downtime, reduce the risk of data loss, and ensure the system continue to run smoothly. Okay, what it was and why we need it? Then why we need it? First, distributed systems are complex with many inherent chaos in the system. To use the Cloud and Microsoft architectures provide us with many advantages, but also comes with complexity and chaos, which can lead to failure. The engineering's responsibility is to make the system reliable as possible. Without testing, we have no confidence to let our project to be used in production environment in order to make it more robust. In addition to the commercial unit test, E2E test, we decide to introduce Chaos test. When an error occurs, repairing it takes time and can cause immeasurable loss, which may have long-term effective in the future. In the process of repair, we need to consider various factors, include the complexity of the system, the type of error, and the process, the possible new problem, in order to ensure that the final repair is effective. Moreover, when an open source project brings a serious fault to users in the production environment, many users will choose to switch other products. Back to today's topic, how to design chaos and experiment for an ingress controller. Let's talk about what is ingress first. Ingress is a resource object in Kubernetes. It contains rules for how clients outside of the cluster can access service inside the cluster. These rules include which client can access which service, how to route client request to the appropriate service, and how to handle client request. On the right is a simple example. As you can see, ingress is uncomplicated resource. No need to make it more complicated than it needs to be. What is ingress controller? An ingress resource requires an ingress controller to process it. Otherwise, it has no practical use. The controller translates the ingress rules into configurations on a proxy, allow external clients to access service within the cluster. An ingress controller is a special type of load balancer that receives ingress rules from the cluster and then translates them into configurations that can proxy client requests. This effectively manages how external clients access service within the cluster. However, in production environment, we need many complex capabilities such as limiting access resource and request method, authentication and authorization. The ingress resource object doesn't include this part, so most ingress controllers extend the semantics of ingress through annotations in the ingress object. Different ingress controllers have different implementations. For example, the annotations used by Kubernetes Ingress NGX and Apache APISIX Ingress are different. Okay, what is Apache APISIX Ingress? Apache APISIX Ingress controller is a controller for Kubernetes Ingress resource that helps administrators manage and control Ingress traffic. It uses Apache APISIX as a data plane to provide users with dynamic routing, load balancing, elastic scaling, security policy, and other features to improve network control and ensure higher availability and security for their business. APISIX Ingress supports 3 configuration modes: Kubernetes Ingress, Customer Resource, and Gateway API. Each of these has its own advantage. For example, Ingress Resource. This is simple to describe, and it is a resource carried by Kubernetes by default. It's also easy to integrate with other components. Next one is Gateway API. Gateway API, this is the next generation ingress, provide rich semantics and functions. The last one is CRD. Apache APISIX Ingress provide a set of customer resource corresponding to APISIX's own resources, which is convenient to user to use and understand. APISIX Ingress adopts a expected architecture with the control plane handling router rules without carrying business traffic. All client requests are processed through the data plane. Therefore, any abnormality in the control plane will not affect the traffic. In addition, APISIX Ingress controller has a retry machine. After the control plane component is restored, the routing rules can be asynced to the data plane. This is the architecture. And the next one, what is LitmusChaos? LitmusChaos is an open source chaos engineering framework and an incubating project of the Cloud Native Computer Foundation. It provides an infrastructure experimental framework to validate the stability of the controllers and microservice architecture. It can simulate control level, container level, and application level environment, as well as nature actor faults and upgrades to understand how the system responds these changes. The framework can also explore the behavior change between controllers and applications, and how controllers respond to the change in the spec status. In addition, Litmus offers convenient observability integration capability. It's highly extendable and integrates with other tools to enable the creation of custom experiments. Kubernetes developers and SREs use Litmus to manage chaos in a declarative manner and identify weakness in the in their applications and infrastructures. Someone asked me why I choose LitmusChaos over other products. That is a topic for another time, but to summarize, LitmusChaos has the function I need, and I'm more familiar with it. Okay, how to design chaos experiments? This is a general process applicable to the design of chaos experiments in any scenarios. First one is to define the system and test. Identify the specific component of the system you want to experiment on, and develop a clear and measurable objective of the experimenter. This includes creating a comprehensive list of the components such as hardware and software that will be tested, as well as define the scope of the experimental and the unaccepted conditions. Choose the right experimenter. Select an experimenter that is aligned with the objective you have set, and close mannequins and real-world scenarios. This will help ensure that the experimental process produced meaningful results and accurate reflect the behavior of the system. Next one is establish hypothesis. Establish hypothesis is about how the system will behave during the experiment, and what outcomes you anticipate. This should be based on past experience or research, and it should be reasonable and testable. Next one is run the experiment. Run the experiment in a controlled environment, such as a staging environment, to limit the potential for harm to the production system. Collect all relevant data during the experiment and store its security. There may be different opinions on whether the experiment should take place directly in production environment. However, for most scenarios, we need to ensure the service level objective of the system is met. The last one is evaluate the result. Evaluate the result of the experiment and compare them to your hypothesis, and analyze the data collected and document any observation or finding. This include identify any unaccepted result or discrepancies, and determine how they might affect the system. Additionally, consider how the result of the experiment can be used to improve the system. The main usage scenarios of Ingress controller. The Ingress controller main scenarios is proxy traffic, and I think it's the most important capability. The other functions are all based on these core functions. Consequently, when conducting chaos engineering, normal proxy traffic is the key matrix. Next, we can use the general model above to define the system and test. For APISIX Ingress, users need to create root configurations such as Ingress Gateway API or CRD and apply them to Kubernetes cluster via kubectl. This process goes through kube APIs for authentication, authorization, admission, and is then stored in etcd. The APISIX Ingress controller continually watches for changes in Kubernetes resources. These configurations are then converted to configurations on the data plane. When a client requests the data plane, it accesses the upstream service according to the routing rules. It's clear that if a Kube API server has an exception, it will prevent the configuration from being created or the Ingress controller from getting the correct configurations. This is obvious and certain scenarios no experimentation is needed. If there is an exception in the deadline, such as a network interruption, crash, or port kill, it will also not be able to do normal traffic proxy. This also doesn't need to be experimented. Therefore, the score of our experimenter is mainly to impact on the system availability, or if Ingress controller has an exception, then we should choose the right experiment. Based on the above reason, we can directly cover many scenarios of incorrect configuration through end-to-end test, mainly through chaos engineering to verify whether the data plane can still proxy traffic normally when the Ingress controller issue an exception such as the DNS error, network interruption, or port killed. And we should establish this for each scenarios. We can create the following hypothesis. When the ingress port get X, the client's request can still get a normal response. Then we can run the experiment. The experiment and the variables have been determined, so all that left is to conduct the experiment. LitmusChaos provides various ways to conduct the experiment. We can do this through the Litmus portal. To do this, we need to create a chaos scenarios, select the application to be experimented on, and these steps are relatively straightforward. However, we must pay attention to the factor that LitmusChaos include a probe resource. Probers are pluggable checks that can be defined with the Chaos engine for any chaos experiment. The experiment probe executor these checks based on the mode they are defined in any and factor their success as necessary condition in determining the validity of the experiment. In addition to standard in building checks, at the same time, we can also schedule experiment, which is very valuable function. Additionally, LitmusChaos also support running experiments by submitting YAML manifests. Next one is evaluate the result. LitmusChaos has built-in statistical report that clear shows the result of the experiment. There are also other rich reports such as compress of experiment, execution records. It can also be integrated.
Hey all, I'm so sorry. The video was moving a little bit slower than I anticipated, and we can't. We need to pause so that we can ask a question, but then we have to start the next event. This video is recorded and it will go out, and Jintao has offered nicely to answer any questions in Slack as well going forward. And again, he's part of the Litmus community, so he can definitely help out through that in the Kubernetes Slack channel as well. Any last minute questions before we say thank you? Okay, I'm just looking in chat and QA. Okay. Well, great. We'll again post this video, and then if there's any follow-up, we can pass it his way. But thank you for joining so late, and I appreciate it. So have a great